differentiation can help us to solve many types of real-world problems. We use derivative to determine the maximum and minimum value of particular functions. For example, cost, strength, profit, loss, and others. Derivative commonly made in many engineering and science problems, especially when modeling the behavior of moving objects. Thus, the important application of differentiation is applied maximum and minimum problems. The terms maxima and minima refer to extreme value of function, that is, the maximum and minimum values of the function which maximum means largest possible quantity. The absolute maximum of a function is the largest number contained in the range of the function. In terms of graph, the absolute maximum value of a function is correspond to the highest point on the graph. Conversely, minimum means least possible quantity. The absolute minimum value of a function is the smallest number in its range and corresponds to the lowest point of its graph. A wide variety of problems can be solved by finding maximum or minimum values of functions. There are many practical applications which need to find the maximum or minimum value of a quantity. For example, in economics, business, and engineering. Finding maxima or minima also has important applications in linear algebra in game theory. For example, linear programming consists of maximizing or minimizing a certain quantity and requires certain constraints be imposed on other quantities. Thus, the key step in any maxima or minima problem is expressing the problem in mathematical terms.
Differentiation is a given function which is x power of 3 negative 5x power of 2 plus 3x plus 2. Question number 1. State the y-intercepts of it. First, we need to know the equation. Then, we replace our x with 0. So, f0 equal to 0 power of 3 negative 5 0 power of 2 plus 3 0 plus 2. So, we've got the y-intercept is equal to 2. How about question number 2? Find the intervals if f is increasing and decreasing. Hence, determine the relative minimum of f, if any. From the equation, we differentiate the function. When f prime x equal to 0, we will get the answer 3x power of 2 plus 10x plus 3. So, the critical value is x equal to 3 and 1 over 3. Then, draw the table of interval, test value, and sign off. We need to fill in the table with information given. So, fx increasing in the interval is negative infinity 1 over 3 united with 3 infinity. If we replace our x with 3, we will get the answer for minimum point, which is 3 negative 7. Next, we can see that the function decreasing in the interval 1 over 3 and 3 from the table. If we replace our x with 1 over 3, we will get the maximum point 1 over 3, 67 over 27. After that, for question number 3, find the intervals where f is concave up or down. Determine the inflection points of f, if any. We'll have the f prime prime x equal to 0. F prime prime x equal to 6x negative 10. So, 6x negative 10 is equal to 0. From the equation, we've got the x equal to 10 over 6. It can be simplified with x equal to 5 over 3. So we've got the inflection value here. Then draw up the table with interval, test value, sign off, and conclusion. For the first table, we will have negative infinity 5 over 3. For the second table, we will have 5 over 3 infinity. Then fill up the test value, sign off, and conclusion. All the information have stated in here. From the equation, we need to replace our x equal to 5/3. Then we've got the answer negative 61 over 27. So we will have the inflection point with 5/3 negative 61 over 27. Then for question number 4, sketch the graph of f using the information. Here is the sketch of graph from the information above. We've got the maximum point and minimum point here. So, hope you guys can understand application of differentiations now.
Our assessment topic, which is differentiation. With differentiation as a mathematical technique, I've been able to reach a clear and simple way to use this method. Each of this method will bring you to understand more clear and simple. Furthermore, with table and figures, I've been able to compare the actual data and the predicted data. Therefore, it will be true if I say that other developing and undeveloped countries deserve to emphasize on the implementation of the family planning rule in order to reduce the negative impacts of massive population that's expected all over the world. This project can therefore be viewed as a scientific effort to measure and manage population growth in the current world setup. It also can help struggling. Using the techniques above, I have been able to predict population size with and without family planning. For an example, I analyzed the family planning policy in China and evaluated how it has advantageously helped China in its development and poverty reduction. The analyzing of the different countries that are less developed has given an overview of how overpopulation will cause several problems. For example, first, instability. Second, showing the country's development. Third, the vicious poverty circle, pollution, and environmental degradation.
It is not necessarily what you teach, but how you teach it that will define the learning experience of your students. Not everything you do means that everybody all of the time, but by using a variety of strategies and giving options within the class, the teacher can be inclusive in the teaching. Knowing what you teach and how you teach, it will give students different learning experiences and allow a teacher to tap into as many different students as possible. Try not to think of differentiation as something added to normal teaching, as something that is part and parcel of the whole teaching learning experience.
Last but not least, I would like to express my special thanks of gratitude to my teacher, Madam Siti Saliha, who gave me the golden opportunity to do this wonderful project on the topic differentiation, which also helps me to know about so many things. I am really thankful to you. Secondly, I would also like to thank my parents and my teammates who helped me a lot in finalizing this project within the limited time frame.